if you would have asked me a few years ago, 10, 15 years ago, that we would again have the challenge of the conflict and struggle between science and faith, I wouldn't have believed you, because postmodernism was on a rise. That means that it's a very skeptical movement in terms of our own rationality and so on. But the new atheist movement, guys like Richard Dawkins and Christopher Hitchens, thank you, Christopher Hitchens, and Daniel Dennett, and a lot of those guys, thanks to them, their voice of atheism has been so loud, and they come from a scientific perspective, and that really made it necessary today to really talk about science and faith. And I cannot think of someone better to do this today than Philip Calcott. He did his doctorate in physics at Oxford University quite a few years ago, and then he practiced for 13 years as a physicist. But then luckily, that was in Britain, of course, luckily he married a South African lady, Juliet. Juliet, we're so thankful for you. Yeah, let's just give her a hand, because Juliet, because of you, we're going to benefit greatly from Philip in the future as well, because she dragged him all the way here. And they're actually living here now. And they're living in the Waterberg area, and Philip is currently practicing astronomer. So he's a scientist by heart and by mind, and he's got a great personal story in terms of the whole conflict, or so-called conflict, between science and faith. And he loves Jesus. I just saw the way you sang, your whole family. Pete, it's great to have you here as well. You are so welcome. So let's just give a warm hand of welcome to Philip Calcott, please.
Thank you so much. Thank you so much, Rudolph, and thank you all. And thank you, worship team. That was just awesome. We loved that as a family. And I just have to tell you, I think God was winking at us, because if I'd asked you to play any song, it would have been that one. My family will tell you I'm just obsessed with that song, How Great Is Our God. And we go into the same hymn phrase that you used there. So that's absolutely wonderful. Thank you so much. Let's just pray and commit this time and my message to the Lord. Father God, I just want to thank you for this opportunity to gather together this morning and to gaze upon your wonder and glory. I just thank you, Lord, that you are this awesome creator God, and yet you're intimate and personal with each one of us. Lord, I thank you that at this very moment you are sustaining the universe, and you have knowledge of the hairs on our head, Lord, and you know us intimately. And we just welcome you by your Spirit here this morning, and may you be glorified. Amen. Amen. Could we have the first slide, maybe? Great. So, I don't know how many of you have ever seen something like this. Maybe just wave a hand. Have you seen the Milky Way in all its glory? Oh, that's a pitifully small number. You need to come to the Waterberg, because you need to get away from light pollution to see something like this. What we're actually looking at here is actually our galaxy that we're seeing from the inside of it. And in this beautiful arc of sort of milky whiteness, you're looking at something like 200,000 million stars. Absolutely awesome. And I think we suffer so much in the modern world with the issue of light pollution. We don't experience this. But I think something like this was probably what David the psalmist was looking at. You know, one of those nights maybe when he was out looking after the sheep, and he looked up and he just said, you know, the heavens are declaring your glory, Lord. The skies proclaim the work of your hands. And, of course, that theme is taken forward by Paul when he speaks in Romans. He says, actually, since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood from what has been made. So I think that you'll all agree there's a very strong theme in Scripture that God's glory is displayed in the heavens. And we can actually see something of the general revelation of God, that there is a creator. It actually resonates with our spirits. There must be someone who made this wonderful glory. But is that still true in an age of science? I think some people have questioned it. So I'd just like to take you on a little journey through investigating whether in an age of science the heavens still declare the glory of God. So here's a picture some of you might have seen before as well. Does anyone know what that one is? I can hear mutterings of Large Hadron Collider, which is quite right. That is indeed the Large Hadron Collider. Just to see scale, that's a person standing there. This is a massive detector. It's called the Atlas Detector, and it detects these subatomic particles that are created in the collisions that occur in the Large Hadron Collider. And it's allowed us to understand that the elementary particles that the whole universe is made of come from this collection of 17 particles. I'm sure you're all familiar with the Standard Model, so I won't bore you with it. But everything is made up out of those elementary particles. And it's a wonderful thing that we've been able to discover that. And I think it's led in some fields for people to become maybe a little bit arrogant about our understanding and knowledge. And some people have claimed, going back to David and Paul, that awe that they described, that sense that the heavens declare the glory of God, that was just ignorance. Now we know better. Now we understand. Science has shown us how it's all put together. We have no need for the hypothesis of God, shall we say. To put this in context, I just really want to look at this question. Does the universe still point us towards a creator in an age of science? Rudolph mentioned the new atheists. Just bringing up a few quotes from them. Robert Park summarized new atheism as saying, the cure for faith is science. Faith is a disease, science is going to cure you of it. You mentioned Richard Dawkins. Science is corrosive to religion, is how he put it. I think he's got a picture there of like faith in God being a sort of lump of metal that you're immersing in a bowl of science, which is a kind of corrosive acid, and it's gradually being eaten away, and there'll be nothing left. And this is actually even more described in this last quotation I'm going to give you. The dogma of Christianity gets worn away before the advances of science. Religion will have to make more and more concessions. Gradually, the myths crumble. That's Adolf Hitler, actually, that one. So it shows this kind of approach is not entirely new and has some disreputable proponents as well as reputable. So is this all true? What I would like to look at is, what does science really say at its deepest level about the existence of a creator? Here's Werner Heisenberg. I'm sure any of you who know anything about quantum mechanics will recognize he's one of the fathers of quantum mechanics. And he says this: the first sip of a glass of natural science will make you an atheist, but at the bottom of the glass, God awaits for you. So I would like to look at the bottom of that glass, at the most fundamental way the universe is put together, and see what, if anything, that tells us about a creator God. So what we're going to look at is something some of you may be familiar with, I don't know, the issue of the fine-tuning of the fundamental laws of the universe. You'll see what we're going to look at is the absolute basic way the universe is put together. How many forces do we have in the universe? What are the masses of the fundamental particles? How many dimensions does the universe have? These are the questions that this is looking at. So a bit of a warning, there is some physics here. If you do feel a bit sick, you can just feel free to put your head between your knees for a while. I'll tell you when it's over, and you can lift your head up again. So here we go. I'm going to start with this rather boring slide, but quite an interesting one, you'll see. This is soot. Now, you might be saying, soot, Phil, that's not very exciting, but in actual fact, it is exciting because it is made of carbon. And carbon is one of the most exciting elements we have. Here's a slightly more attractive version of carbon. You ladies might appreciate it a little bit more. And it illustrates one of the amazing things about carbon. Carbon is this incredibly versatile element. It can take on many, many forms. Here's another form of something that uses carbon intimately. I don't know if any of you know what that is. That actually is a rhodopsin molecule. And rhodopsin is what makes the pigment in your retina. So you're looking at this rhodopsin molecule using your rhodopsin molecules at the moment. Without rhodopsin, you wouldn't see. And I'd just like to talk you through that. What they've tried to represent this molecule by lots of spheres, each sphere being an atom. The white ones there are hydrogen. The red ones are oxygen. There's some yellow ones, that's sulfur. I think there's some blue ones somewhere. But the ones I really want you to pick out are the gray ones. The gray ones are actually making the backbone of this whole molecule, and they are carbon. And in actual fact, the whole of life is built together, the whole of life holds together because of carbon. Carbon is the most versatile element, and it forms the backbone of everything in your body. All of your lipids, all of your proteins, all of your carbohydrates, they're all built around carbon. Without carbon, the chemistry of our world would not be sophisticated enough to make anything like life. So, do you ever sit in the bath and wonder, where did all that carbon come from? You should, because it's a really interesting question. When the universe was made, we only had two elements, hydrogen and helium, very, very simple elements. Nothing, you can't really make anything interesting out of hydrogen and helium. We had to create carbon, and all the carbon in your body, sorry, there's a little picture of carbon, all the carbon in your body, you may or may not know this, was actually made inside a star. 90% of your body is actually stardust. We are made from the debris of dead stars. There's a whole story that I'd love to tell you about. If you come to the Waterberg, I'll show you how it happens by looking at the night sky. But yeah, we were made inside a star, and the process by which we were made is really, really interesting. This is basically how it goes, and this is where the physics begins to get a bit hairy, but just hang with me. So what you have to do is you have to take 3 helium nuclei and crash them together to make 1 carbon. Gives out a lot of energy in the process. It's one of the major reactions that fuels stars. But you can't do that in one go. You can't crash 3 tiny things like helium nuclei together. You have to do it sequentially. So this is what you actually have to do. You have to, first of all, crash 2 heliums together to make a beryllium nucleus. Then you have to crash those together to make a carbon. We add, an extra helium. And then if you added an extra helium, you would actually destroy the carbon you've made and make oxygen. Okay, so that's obviously how it works. There's a problem. The problem is the beryllium is rather short-lived. It doesn't hang around for long. And when I mean short-lived, I mean really short-lived. Beryllium has a half-life of 1/10,000th of a millionth of a second. So imagine trying to make something when your building blocks only stick around for 1/10,000th of a millionth of a second. It's a bit tricky, a bit of a challenge. So what you've got to do, there's only really one possibility. And an amazing guy called Fred Hoyle, I don't know if any of you heard him, brilliant, brilliant physicist, probably the greatest physicist never to get the Nobel Prize because he was a rough diamond, shall we put it, and annoyed everyone, so they didn't give him one. But he worked out how this worked. He realized, first of all, that we had carbon, obviously. We're made out of carbon. And he looked at the reactions and he said, this is actually impossible. This beryllium just falls apart too quickly. And any carbon we make will get turned into oxygen. And he thought about it, probably in the bath, and he realized that there was one possible way that it could work. And it could work if you dramatically enhanced the rate of creation of your carbon, and you dramatically suppressed the rate of creation of your oxygen. So basically this process here has to be dramatically enhanced, and this one has to be suppressed. And Fred was a very, he verged on the side of arrogance, shall we say, and he went along to the nuclear energy tables, and he realized what you needed for this to happen was an energy level of the carbon nucleus that had a resonance with this beryllium and alpha reaction. And if this energy level sat at exactly the right level, you'd get this enhanced creation of carbon. And he looked in the nuclear energy levels, and it wasn't there. Now, a lesser person might have thought, oh well, that was a good idea, but obviously it doesn't work. Not Fred. He realized that that was the only way to create carbon, and we had carbon. So that energy level had to be there. So he went along to his experimentalist friends, and he said, I've got good news and bad news. The bad news is, you're a lot of incompetent experimentalists because you've missed this energy level. The good news is I can help you out and tell you where it is. So this obviously went down very well. And it took 2 years for him to persuade his experimentalist friends to go and look and do the experiment again. And when they did, they found exactly what he predicted. And let me just show you how it works. So basically what you've got here, this is energy, an energy plot. Vertical axis basically represents energy. You've got your beryllium and alpha nucleus, and he worked out that basically carbon had to have an excited state exactly here. It had to be slightly above the energy of your beryllium and alpha, because when the beryllium and alpha crashed together, they would have excess energy, and the only way you could conserve momentum and energy was if that level lay slightly above. Too high, and it wouldn't work. Too low, and it wouldn't work. So they did the experiment, and the result was, bang. This energy level lay exactly where it was meant to. Now, Fred thought about this, and his comment on this was quite interesting. He basically observed that the laws of physics had to be incredibly fine-tuned to produce this resonance. The resonance is dependent on the strength of the strong nuclear force, the strength of the magnetism, the masses of all these elementary particles, and they all had to be lined up on a beautiful knife edge, as it were, to actually get this effect. And his comment on this, and remember, this is a guy who was an atheist, but was also a very good scientist. This was his comment. A common sense interpretation of the facts suggests that a super intellect, he didn't like the word God, has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. It's quite amazing. But is that just an isolated instant? Well, the extraordinary thing is, as we've dug into physics, as we've looked at the bottom of Werner Heisenberg's glass, as it were, as we've dug in deeper and deeper, the number of these extraordinary coincidences has proliferated immensely. The Higgs Boson, I'm sure you all heard about its discovery. There's another extraordinary fine-tuning associated with that. But I'm not going to talk about that. I'm just going to share one more with you, which is to do with the origin of our universe and the creation of our universe. But just to emphasize, there are an extraordinary number of these fine-tuned events that actually people have discovered. But our present understanding of the universe is that it emerged in this massive expansion of space-time, which people call the Big Bang, rather a bad name for it. But in the process of the Big Bang, there's something that's really, really important we've discovered. It's called the Cosmological Constant. And it's sort of annotated by a capital delta, Greek delta, and it plays this really important role because it drives the increasing rate of expansion of the universe. You probably all knew the universe was expanding. Some of you might be aware in 1998, we discovered that that rate of expansion is increasing, which was quite a surprising discovery. But it also can be described in some way as the energy density of free space. It turns out, in quantum mechanics, you can't strip all the energy out of space. Even if you have a vacuum, there's still something there. And that's a good way of describing the cosmological constant. And in particular, one major contribution to its size is this thing called zero-point energy. How many of you have heard of zero-point energy? Again, a pitifully small number. If you haven't, you must go and watch the Incredibles movie. How many of you watched the Incredibles? It's a great, that's good. Great, great movie. Do you remember that bit where Syndrome zaps Mr. Incredible? And he says, zero-point energy, really cool? You see. Actually, that's rubbish. You can't do that with zero-point energy. But it's a great little, publicity for zero-point energy. Zero-point energy is a real thing. It is a thing, and it contributes to the cosmological constant. So, the cosmological constant, I'll come to zero-point energy in a second. This guy called Weinberg, he sat down and he thought about the cosmological constant, Stephen Weinberg, and he realized that in actual fact, for a universe that could sustain life, it had to have a value within quite a tight range. The reason is, if it was too small, the universe would actually collapse on itself too quickly, and if it was too big, the universe would blow up too much. And it had to be just right to create these stable conditions, which we experience, that allows stars and galaxies and all these wonderful things to form. And so in 1989, he said, guys, the cosmological constant, if we measure it, it's got to be a certain value. Okay? And we measured it, and it's got exactly the value Stephen Weinberg said. Fair enough. What's the big deal with that? You can also calculate it. And this is where the zero-point energy comes in. Because the zero-point energy is one of the contributions to it. And if you calculate that, it turns out to be 10 to the 120 times too big. Now that's a big number. That's 1 with 120 zeros on the end of it. Just to put that in perspective, there is something like 10 to the 85 atoms in the observable universe. This is something like a trillion times bigger than the number of atoms in the entire observable universe. So this is a problem. This has been described as the largest discrepancy between theory and experiment in the whole of science. And it really stresses physicists out, actually, if they're honest. So what's happening? There's only one way we can resolve this apparent contradiction. And it must be that there are other contributions to the cosmological constant that almost, but not exactly, cancel out the zero-point energy. Do you see what I mean? So the zero-point energy, this massive positive contribution, there must be some equally massive, but not quite exactly the same, negative contributions, and they cancel out and give you this tiny, tiny, tiny positive value. Just to give you an example, I'll use something that hopefully we can relate to a little bit more. The American trade deficit. So the trade deficit is a bit like this. You've got a positive contribution, you've got a negative contribution, and when you take the two away, you end up with the value that is the trade deficit. So this is a little graphical representation of that, in case you can't see the numbers. So what you're looking at here is the amount of goods America exports, the amount of goods they import, which is always bigger, of course, because Americans are great consumers, and the difference is the trade deficit, which sits at about $1 trillion. So you've got the difference of two very large numbers, still gives you a pretty big number. Now imagine one day the head of the Fed has this press conference and he says, guys, something amazing's happened. I just want to tell you that the American trade deficit, the difference between what we export and import this year is 1 cent. 1 cent. It's just almost, but not entirely, exactly cancelled out. That would be a way smaller coincidence than the cosmological constant. You've got a massively more complex and extraordinary cancellation that gives you this number. And I tell you, you look on the blogs and websites of cosmologists, atheists, Christians, they all stress about why the heck does this cosmological constant have its insanely small value, which just incidentally is required for life. So it's a bit like coming along and seeing something like this. This is physically possible. You could have a dollar bill and have those 5 coins balanced exactly on the top of it, but it's not really going to happen, is it? The fact, if you came across that, your conclusion would be, as Fred Hoyle said about the fine-tuning with carbon, he said, this is a put-up job. And that is the obvious conclusion. The obvious conclusion that we can draw from all of this is, in actual fact, the universe is fine-tuned. I just want to give you a few quotes from very famous atheist cosmologist and physicist, because I want to emphasize this is not something Christians have cooked up. This is absolutely standard physics. Here's Paul Davies, very famous cosmologist. There is now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. And here's Stephen Hawking, the greatest theoretical physicist of the 20th and early 21st century, sadly now died. He's the guy in the wheelchair with motor neuron disease. He said, the remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. So what's going on? What can we conclude from this? Well, I'd like to suggest to you that the obvious conclusion is that our universe is not a purposeless occurrence. It's actually been designed with life in mind. Extraordinary thought. When this whole thing was put together, and the fundamental laws, I would say, were decided upon, it was made to allow life to be possible. I just want to emphasize here that if you change them ever so slightly, you would have a universe, but it would be a dead universe. Our universe is just balanced on this knife edge of catastrophe. You change these things ever so slightly. And again, this is not my opinion. This is an absolutely well-established fact in physics and cosmology. You would end up with a universe, but maybe one in which stars couldn't exist. Or maybe one in which stars burnt up much too quickly. Or maybe one in which various nuclear elements were created that were not conducive to life. We really do live in an extraordinary universe which seems to be designed for life. Okay, so that's, I think, the obvious conclusion that one can draw. How can one avoid the obvious? Well, I'd just like to talk about two possible ways in which people who don't want to accept the conclusion that our universe might be designed, hence created, they try and avoid that. One is called the Anthropic Principle. I don't know if you've heard of the Anthropic Principle. It's often tossed around. It's really interesting. Let me just throw it up here. What it says, the universe must be able to support life, or you would not be here to observe it. Think about that. It's got to be true, hasn't it? If the universe couldn't support life, there wouldn't be people, so there wouldn't be any observers. So that's true. But I would argue it's not an explanation of why the universe is able to support life. Let me just use an analogy from John Leslie here to support this. He gives this wonderful analogy of a firing squad. Now, let's imagine that you're unfortunate enough to run foul of an evil dictator, and he wants to make an example of you, and he's going to have you shot at dawn. So at dawn, you're tied to this post, and you have a blindfold put across you, and he really wants to make an example of you, so he assembles not just 4 riflemen, 120 riflemen, all of whom are expert marksmen, and any individual one is incredibly unlikely to fortunately miss you. And the signal's given, the guns will go off, and to your amazement, you're still alive at the end of it. Now, the Anthropic Principle says you should not be surprised that you are not dead, because dead people are not surprised. So that is absolutely true. But it is still true that you should be surprised you're still alive. That does still need explaining. Maybe you had a friend on the inside who the night before your execution swapped all the live ammunition for duds or blanks. It still needs an explanation. 120 marksmen all missing you? You can't just say, well, you know, if I was dead, I wouldn't observe this. I'm alive. I had to be alive because I had to observe this. That's not an explanation. It's actually a tautology. So we can forget the Anthropic Principle. Let's move on to a second one, which, again, I'm sure a lot of people have heard of. This is the multiverse hypothesis. And this actually is a potential explanation of the extraordinary fine-tuning of the universe. It goes like this. There are a near, possibly infinite number of universes with different sets of physical laws, and we are just living in one of the incredibly few lucky ones that can support life. So if this was true, it would be an explanation. But probably already you're kind of thinking, wow, really? And what we're talking about here is not really different parts of our universe. The idea is a vast, absolutely vast number of other universes, in principle, never accessible from our universe, out there, each of which might have different sets of the physical constants, different sets of the physical laws. So if you have enough of them, you're going to get lucky, and we're just in one of the lucky ones. It is a kind of explanation, but is it a good one? Well, physicists really, really don't like the multiverse. Paul Steinhardt from Princeton, his comment is, the multiverse idea is baroque, not a Christian, is baroque, unnatural, untestable, and in the end, dangerous to science and society. I could go into why physicists hate it, but there is an increasing number of people who say this is not science and is actually dangerous to science. And one of the big issues is the untestable nature of it. We're never, ever going to be able to get evidence for the existence of these multiverses. So it's famously described as Peter Voigt has a wonderful blog that he calls Not Even Wrong, that he set up to basically attack the multiverse. Not even wrong is an expression physicists use to provide the ultimate condemnation of a physical theory. You know, if you come to your professor with a theory where you've made a mistake, he'll go, this is wrong because of equation 6, you know, here. If it's utterly ridiculous, he'll look at you and say, Phil, this is not even wrong, you know. That's the ultimate put down, and that's what his blog is called. And the issue of verifiability is really important, but there's a lot more to it that I won't, you'll be very glad to hear, I won't subject you to, but basically it requires the veracity of a whole pile of really controversial theories. So the most controversial string theory and the compactification essential to string theory, but it also requires a series of fine-tuned physical theories. So can you see the problem here? We're invoking fine-tuning to try and get rid of the explanation of fine-tuning. So it's basically eating its own tail here. So people don't like, a lot of physicists don't like the multiverse. There's a whole bun fight going on with physicists, not Christians, saying, guys, you're actually undermining what science means with this interpretation. Bernard Carr summarized it like this. He said, if you don't want God, you'd better have a multiverse. And I think he's right. For a number of physicists, that is their motivation. They really don't want to face the possibility that they might have to accept the existence of a creator. Okay, so what can we conclude? I would say the arguments I've presented, and this is quite important, this is not a proof of the existence of a creator, but they do mean that not accepting a God carries, all right, struggling with my pointer here, clicker here, whoops, there we go, carries an intellectual cost. There's quite a heavy burden in concluding that this either all happened by chance or this multiverse thing is the explanation. So you can do it, but it might keep you up at night. It requires quite a bit of faith in your atheistic worldview. Arno Penzias, Nobel Prize winner in physics, not a Christian. This was his comment on it. Astronomy leads us to a unique event, a universe which was created out of nothing, one with the very delicate balance needed to provide exactly the conditions required to permit life, and one which has an underlying, one might say supernatural, plan. I think that's a lovely way of summarizing it. When we look at the evidence and take it on face value, it really points us towards plan, purpose, meaning, destiny, a universe that saw us coming, a universe that was actually prepared for us. I found this very, very exciting. One further concluding thought, and then I'm going to share a little bit of personal testimony that relates to this. Everything that we've discovered so far points in a direction of a creator, but it doesn't tell us anything about the nature of the creator. If our universe was created, who did the creating? So far, I would say the fine-tuning of the universe strongly indicates we live in a created world, but it tells us nothing to do with the nature of that creator. Is he an indifferent creator? One who just, we're maybe like his fish tank, you know, he created this and he just looks at his fish occasionally and interesting to see how they're suffering or having fun or whatever. Or maybe he's a cruel creator who actually actively enjoys the difficult things that we experience in life. Or maybe he's a loving creator. And I'm delighted to say that the creator did not leave us wondering. And I just love this picture because for me, it summarizes this amazing message that we as Christians have and no one else has. The creator and sustainer of the Milky Way and all the galaxies out there did not leave us wondering. He became a man, which is extraordinary enough. He bore our sin and died an agonizing death on the cross. And I think about this every day, and I can't get my head around it. It's too wonderful to understand, isn't it? The creator and sustainer of the universe cares about me and cares about you. It's absolutely amazing. It's absolutely amazing. It's the most wonderful fact in the whole world. And the most amazing thing in the history of the world is that this happened. And this is our gospel. I don't want to persuade you we have a gospel of the fine-tuning of the universe. We don't. You don't have to understand all of that. You just have to understand this. This is our gospel, the death and resurrection of Jesus Christ. And I'd just like to share a little bit about my personal story as relates to this and how God, we've talked about this transcendence of God, if you want to have it, this massive, awesome God who's out there. I just want to talk a little bit about the immanence of God, how he's a personal God as well. And the story is my story of 2019, last year. It's a rather embarrassing start to the story because I've got an admission to make. And my admission is that when I read the Bible and when I read Psalms, I used to rather ignore Psalm 23. I don't know why now, but I think it was overdone. You know, Psalm 23 was such a popular psalm. I'd almost skip over that. And then in January of last year, something happened. You can ask my wife about this afterwards. God just zapped me with Psalm 23. The Lord is my shepherd, I shall not want. He makes me lie down in green pastures. He leads me beside still waters. And particularly this phrase, he restoreth my soul. That just hit me in the gut. And for about 2 months, if you bumped into Philip Calcott, he'd probably say something about Psalm 23. I got really boring. It was just wall-to-wall Psalm 23. And the next phrase, yea, though I walk through the valley of the shadow of death, I'll fear no evil, for thou art with me. That was really significant to me as well. So I was happily going along, and then on the 19th of March, I understood why a gracious God had explained that to me. I was staying here in Pretoria, which itself was miraculous, just actually around the corner from this church. And I woke up on the 19th of March, and I had a pain in my left eye. And it felt like someone had tipped pepper in it. It was quite a sharp pain. And as I reached to sort of brush my eye, I realized two things simultaneously. One was the pain wasn't in my eye, it was in my brain. And the other was I was completely paralyzed on the right-hand side of my body. I was actually having a massive stroke, and I turned to my wife, who was asleep, and I said something like, oh, hi, because I couldn't move the right-hand side of my face. And then it's all a bit of a blur. You know, you become part of a process. The emergency services kick in, strapped to a gurney, rushed to Pretoria East Hospital. I have a very clear memory of being strapped to a gurney and, you know, rushed along those hospital corridors, and you can just see the lights just flicking past above you. And you feel like a lump of meat. The doctors come and they stick all sorts of needles and drips into you, and they stick your head into a CAT scanner and everything like this. And my friends have said to me, Phil, that must have been so scary. And do you know what? The extraordinary thing I can say to them is, I wasn't at all afraid. And do you know why? Because God had spoken to me through Psalm 23. And as I was strapped on that gurney, being rushed along that corridor, and frankly, I didn't know whether I was going to see the 20th of March, or whether I was ever going to be able to use the right-hand side of my body. That phrase, yea, though I walk through the valley of the shadow of death, I will fear no evil, went through my head. And if I died, I will dwell in the house of the Lord forever. I mean, what's there to fear? And it was only later that actually I was introduced by my neurosurgeon to the issue of how much I should have feared if I hadn't have known that. Because let me just take you on a brief trip through my brain. This is an ordinary brain, which my family will tell you I don't have. For various reasons, part of it is missing. But anyway, I want to just introduce you to your ARAS. You might not know you have an ascending reticular activation system. That's that blue bit here. And it's really, really important. It's basically the on switch for your brain. If that gets damaged, you go into a coma and you never wake up. And that's kind of what should have happened to me on the 19th of March. As my neurosurgeon said, Phil, strokes like yours to the brainstem are very rare and almost always fatal. They're very good at sort of, encouraging you like that, neurosurgeons. So this is my brain. I don't know if you can see that gray bit there. It looks quite small. Those are the cells that died in my brain on the 19th of March. It looks small, but it is in the most sensitive part of your brain. This is your brainstem. This is the bit that controls the most basic functions. In fact, this bit that's been targeted here is called the pons, which means bridge, because all your neurons, all your motor neurons, go through that bit to control the rest of your body. So that's why half of my body was completely wiped out by that stroke. But even more significantly, this is your ARAS behind here. I'll just highlight it to sort of show it. And can you see? Basically, the grey dead cells come right up to my aras and stop. People sometimes say I came within a millimeter of death. I came within a millimeter of death. It was that close. And when my neurologists and neurosurgeons looked at my MRI, they said, gosh, you're really lucky. You're really lucky. And I say, no, I was really blessed. My shepherd, my good shepherd, knew what the future he had for me, basically. So that's pretty miraculous. But some of you may have noticed I'm not entirely paralyzed on my right-hand side. And there's a story around that. Because I was obviously in hospital for quite a long time, and I had a wonderful set of OTs and physios, and they worked on me, and I'm sure it was very boring for them. It was very boring for me as well. And it wasn't going well. It was actually funny. I met up with my old occupational therapist 5 weeks ago, and they were so good at being positive. Oh, you're making great progress, and every stroke recovery is different, and you don't know how much you're going to improve. But what they were actually saying in their meetings about me was they were really worried, because I had shown some improvement initially, and then I'd plateaued. And in particular, I couldn't use my right hand and my right arm. And in actual fact, it was so unused that the muscles began to atrophy, and because it hung as a dead weight, the ligaments began to stretch, and my whole shoulder was like weirdly lopsided because it was sort of semi-dislocated. And when I was let out of hospital for good behavior, or not, as the case may be, I was a bit of a pain to them. They sent me home without use in my right hand, basically. And 4 months after my stroke, I still couldn't use my right hand. What I could do with great effort is I could clench my fist. It turns out that the nerves and muscles to make a fist are much stronger than the ones to open your hand out. Something else I discovered. And so I would do that, and then literally I'd have to open my hand up with the other hand. And this was really unfortunate. It means, and I couldn't move my thumb. So basically, I could not pick up a glass. I had this wonderful occupational therapist, Marlies van der Sluis, who for about 7 weeks tried to get me to pick up a cup, and I couldn't. At the end of all that time, I could not, every day, an hour of physio, I could not pick up a cup. Anyway, on the 11th of July, that was my situation. Lots of people had prayed for me, and nothing had happened, really, to be honest. And then a friend of mine called Denise, a very, very dear friend at church, she phoned me up and said, Phil, the Lord's told me to come and pray for you. Can I come around and pray for you? And I said, yeah, sure. Lots of people have prayed for me, but I'm open to more prayer. She came round, she put her hand on my shoulder, and she prayed. And as she prayed, I felt this cold flow down my arm, and it's just an amazing feeling. I thought, something is happening. This is really exciting. She prayed for about 15 minutes, and she finished, was full of expectation, and nothing had changed. So she went home a little bit disappointed. I took a 30-minute nap, because in those days I was taking a 30-minute nap, and usually after a nap, when I woke up, everything was a little bit less functional and more stiff. But I woke up after this 30-minute nap, and instantly I could feel something had changed, and basically my hand had come to life. It was absolutely extraordinary. We've actually got a video that I should have put up of that evening, me eating my supper with both hands, and I'm kind of in between mouthfuls. I keep saying, I couldn't do this. I couldn't do this. This is amazing. I couldn't do this before. And for about 3 days, again, I became really boring because everyone I met, I showed them what I couldn't previously have done. It was just extraordinary. And now I've got basically complete use of my hand. And I met Marlies, as I said, about 5 or 6 weeks ago. And I said to her, Marlies, does this happen? Do you get this sudden, dramatic improvement, step change in recovery 4 months after a stroke? And she said, no, that doesn't happen. I've never, ever seen that. So, it's so exciting to me this morning that I can talk about this enormous, awesome creator God who holds and sustains the universe, and I can testify to you that he is a personal, intimate God. And last year, I don't know why I had a stroke, but I can tell you that in his grace, the Lord prepared me for it, and the Lord healed me afterwards. And it just blows me away. In some ways, it's one of the most challenging years of my life last year, but in some ways, it's the most wonderful year of my life as well, because I have experienced the work of the shepherd, the good shepherd in my life, in a way I never ever had done before in my entire life. And in particular, you know, Psalm 23, yea, though I walk through the valley of the shadow of death, I will fear no evil. I took a hike through the valley of the shadow of death, and I came back because of the grace of the Good Shepherd. But, of course, one day, I'm going to take a more permanent trip through that valley, and we're not going to come back. And I can honestly say, I'm not at all scared. I know who's going with me. And I just want to throw that out to all of us, actually, this morning, because the human death rate's pretty close to 100%. So all of you here, you are going to take a hike through the valley of the shadow of death at some stage and not come back. And I think it's really worth thinking, do you want to do that on your own? Or do you want to do that with the Good Shepherd, creator and sustainer of the universe, by your side? Which sounds better? I mean, this is the choice we have. And also, just two cases, maybe you know the Good Shepherd already. I just want to encourage you. You do not need to fear the valley of the shadow of death. You do not need to fear taking a little hike through and coming back. You do not need to fear your final journey, because the Good Shepherd will be with you. He was so with me. And I could share many other amazing testimonies of that time. But I also just want to say to any of you who do not know the Good Shepherd, I really want to say to you, do not leave it one day longer. None of us know how many days are ordained for us. On the 18th of March last year, I had no idea what was coming my way. But the Good Shepherd did. And I just really encourage you, if you do not know the Good Shepherd, today is a really good day to decide to meet him. And I'm sure if you wanted to come forward at the end of the service here, there will be people who can introduce you to the Good Shepherd, the creator and sustainer of the universe, who will never leave you or forsake you and will go through any challenges. And should you face a stroke, a heart attack, cancer, the Good Shepherd will be with you. And eventually, you'll live in his house forever. I can't put it more clearly than that. I think to reject him, to refuse to allow him to walk with us and be there for us, is the biggest mistake we can ever make in our lives. And I would really encourage you not to make it this morning.